Hey guys, let's go over transcription, and I want to talk a little bit about it, but I don't want to go over the entire process. You have a PowerPoint slide, you have videos online already. There's a lot of resources that are showing you what transcription is. But what I can do for you is even better. I can tell you what do I want you to be able to do. What do you need to know? And that's going to be this video. Just before we start, I just encourage you to link that to the material you've seen in lab last week for the Wednesday section, or you are doing this week for the Monday section. I'm thinking about the first part, the PCR, and that's really a similar process. In the PCR, the temperature changes to open up the DNA, whereas in transcription, the cell's temperature is not changing. What's happening is the RNA polymerase is capable of holding that DNA open just for a tiny bit to squeeze in one side. In PCR, remember that the replication is happening on both sides and the DNA completely separates. So it's completely different but using the same principles. Okay, with that being out of the way, make sure you make link with the lab all the time. It's really going to help you. With that being out of the way, let's talk about what you need to know for transcription. Well, you really need to be able to do transcription yourself. So if you start with a DNA sequence, you need to be able to get from there to the RNA. That's as easy as that, but you will need to be able to do it. And then we'll put that in another video for translation, what you do from RNA to protein. And more than likely, you should work on those things as going from DNA to RNA to protein at once. And that's really a skill we need to be able to have. You need to have that skill. So if we start with the original DNA sequence, the DNA sequence that we will start with, and I'm doing that as you should do it at home. You don't need to like have internet or anything. You can just use a whiteboard, a piece of paper. How do you do this? You just come up with it. So you just say A, C, T, G, 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 A, C, T, G. I don't know, just made it up, like literally. Now you're a sequence of DNA, and you're asking yourself, well, what is the transcription of a DNA? And notice how I didn't give you the entire sequence. Although, you know what? Let's do that. Let's give you the double-stranded of the DNA. That would be a good exercise. Let's do that. So what would be the complementary strand of DNA? It would be T, T, G, A, C, 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 T, G, A, C, right? And this is DNA. You have nucleotides in order, right? Doesn't matter the prime 5, 3, but I mean, if you want to get technical, you can always say like 5, third, 5. Well, there you go, you got it. Now I'm asking you, well, I want to know the RNA. So in transcription, it's all about getting from here to there. And remember, you have different approaches to that. You only use one strand, and if you want to keep the same orientation as you have in the PowerPoint, in most of the videos, the bottom strand of DNA is going to be transcribed. So if we go with that, we're going to just find the complementary sequence to that strand, making sure to replace all the T's with U's. What do I mean with that? I don't mean to replace the T's here by U's. I mean to find the complementary strand of that. So let's do that. A, C, T, G, 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 A, C, T, G. Okay, so that's a complementary. But now I know in RNA, T's are U's. So I'm going to replace the T's with U's. Right? And here you go. That's your RNA corresponding to this strand. And now you can probably put two and two together and notice some little tricks. Well, the little trick is once you have a double-stranded, you literally, if I tell you, give me the transcription of that strand, take this one, replace the T with U's. If I tell you, give me the transcription of that one, take this one, replace the T with U's. What you don't want to do is take that one for, if I say transcribe this second strand, and you just replace T's with U's, that's not going to be correct, right? So make sure you understand that if RNA polymerase is transcribing the strand, the bottom one, it's finding complementary nucleotide to the one on this strand, which happens to be the top strand. And every time it hits A, instead of putting a T, it puts a U. And that's it. That's transcription. So you really want to just do that yourself. Come up with random sequences. It has to be A, C, T, and G's. It can be repeats. None of it matters. Come up with random sequences, find the complementary or not, and ask yourself the transcription. A trick, things you can make it more difficult, is to say, oh, this is my DNA. I'm not giving myself that strand, and now I'm saying, what is the transcription of this strand? Now you just have to do the work to transcribe. So first, you will write down here that is going to be T T G A C C C T G A C, and then you replace all the T's with U's. U, and done. So it can make it a little bit tricky, the things, but you're trained. Do more and more of those.